coming up with some words to talk about functions. And we ended up using words like input, output, X, Y. We found these new vocab words that we might not have remembered. But a function specifically is a relationship between X and Y in which each input has exactly one output. And then the key word here, the most important part of this, is exactly one. So what that means is, when I say input, do you think X or Y? X, yes. Input is X. So that makes output the Y's. Very good. Okay. Now, what I do to help me remember what I'm looking for is I'm going to focus in on any repeated X's. Repeated X's is not necessarily bad. Like, it's fine if they repeat. But what you don't want is repeated X's to go to different Y's, because they can only go to exactly one Y. So I'm going to write down focus on repeated X's. I don't know if that needs an apostrophe. I'm not an English person, but I put one. Okay, so I'm going to look at the first one. We've got time compared to distance. On the left-hand side is always going to be your X's. They're not going to switch it up. X is always on the left. Y is always on the right. I usually do the first type of a problem just for you so you can look at it. So what I look through on this one is I'm going to look at all of those X's, 0, 1, 2, 3, 4, 5. Any repeat X's? So nothing to focus in on. If I have no repeated X's, then there's no way that I'm going to have repeated X's going to different Y's. So this one's totally fine. This one is a function. Did anyone notice that we have some Y's that repeat? Anyone notice these? Anyone think that was bad? That's fine. It's fine for Y's to repeat. That's okay. Okay for Y's to repeat. Alright, so the only acceptable AP, remember in pre-cal you're going to have to take an AP test. The only acceptable AP explanation for something being function is to say each input has exactly one output. I actually learned that this year. If you say each X has exactly one Y, you'll get points off. If you say passes some sort of test, you'll get points off. So the only acceptable explanation is to say each input has exactly one output. And you're going to get tired of writing that. Each input has you already wrote the wrong explanation, I know. It's nice to write it shorthand, but that's what they want to see, because you do have free response questions on the AP test. Exactly one output. Okay, second one. Again, X's are on the left, Y's are on the right. Do we see any repeated X's that we need to focus in on? Yes. Now again, that doesn't necessarily make it bad automatically. Okay? We've got 3 going to 54, and we've got 3 going to 84. Ooh, is each input paired with exactly one output? No. So this one is not going to be a function. Not a function. And the reason is, when X equals 3, it has different outputs. X equals 3 has different outputs. Okay, third one we're going to do a little ink pair share on. For an ink pair share, that means you're going to do it yourself, and then we're going to pair up and share with a partner what we thought. Now I know this one looks a little different. This one's called a mapping diagram. For a mapping diagram, instead of doing rows, they still put the X's on the left, they still put the Y's on the right, but the way they pair them up is they pair it up with arrows. So instead of saying like, oh, -2, 4 is in one row, they just use an arrow showing -2 goes to 4. So we're going to do a 30-second ink pair share. I want you to write down what you think on this one, whether it is a function or not, and then we'll pair up and share. We might not even need 30 seconds. Remember to write official reasoning. You got to get in the habit of that for our future upcoming AP tests. Don't just say the rows matched right. That doesn't work. 10 more seconds to figure out whether it's a function or not. Okay, For an ink pierce here, remember I usually do just base it on colors on your desk. For this one, I'm going to do, let's do pink shared with yellow, purple shared with green. Pink shared with a yellow, purple shared with green. What did you think? Is this a function or not? If you're an odd man out, guys, if you're like in an odd group like this gentleman right here, he's going to wait for the people next to him to share, and then he'll share with them to make sure his thoughts get said also. What do we think? Was it a function? Yes, totally a function. Each input has exactly one output. You could have said, okay, -2 goes to 4, -1 goes to 1, 0 goes to 0, 1 goes to 1. Each x only goes to one way. Function, each input is paired with exactly one output. All right, grab your whiteboard out of your desk. Doesn't matter which one you use, graphing one or a blank one. Markers are in the middle. If you grab a red marker, sometimes the reds are really hard to erase, or sometimes they're super faint and you can barely see them at all. Okay, let's see if we can figure out, let's take let's take a minute and see if we can draw a mapping diagram. So something that looks like this, where you have two circles, and we want a mapping diagram that would be not a function, but I don't want you to repeat any numbers over here. So 1 minute to draw a mapping diagram, just to the best of your ability if you can, that would not be a function, but I don't want you to repeat any of these x's. Great question, I know. Yes, sir. There's not one in your desk? Diagram that would not be a function. I know it's a tricky one. There's usually only one person in a group that can figure it out. But you're not allowed to repeat any of the x's on the left-hand side. Oh my God, I see people slowly getting it. I see people figuring it out. I see one in each group already. Let's share with our group what we came up with. I'm not going to do based on colors. Let's do person closest to the door is going to see if they came up with it first. So in your group, whoever's closest to the door is going to share first if they figured it out. Oh, you got it. Yeah. You got it, Jose. You figured it out. If it's punched in, I was so I put 2 down. Yeah, I did it. Maybe you should call me. You figured it out. All right, what was the trick? How do you have to draw it? It's got to have what? 2 arrows coming out of one of the x's. Right, 1, 2, 3. That's a 5. So you have 2 arrows coming out of one number, because that would show an input going to 2 different outputs, which would make it not a function. Tricky. I'm proud of some of y'all figuring that one out. Okay, whiteboards to the side. Keep your whiteboards out in case someone walks in. They'll see, oh, we did a whiteboard question. Points for me. Okay, next up. If you have a graph, anyone know the name of the test we can use if we have a graph to figure out if it's a function or not? What's the name of that test? The vertical line test, yes. Regina, if you remember what the vertical line test is. Okay, let's explain to our group, the one person in your group that knows. Explain to your group.
Okay, so you draw a vertical line, and if the vertical line touches
Yes, it's a test where if you can draw a vertical line anywhere on your graph, and it hits more than 1 point, then it's not a function. Now, do we get to say passes vertical line test or fails vertical line test on the AP test? No, they're terrible. We have to say each input is paired with only one output. How exciting, right? All right, looking at the first one. I'm going to do the first one with you. So I'm looking all across the graph. Is there anywhere where I can put a vertical line and it's going to hit 2 points on that little graph that we have? Looks like one here, one here, one here. All right, we're good. What do we say then? Is the function because each input has exactly one output. I know, it's going to become the bane of our existence. Do you think I'm going to ask you for this definition on a test?
Yes.
Probably. Yeah. Maybe make a note of that. Each input has exactly one output. All right, let's do second one together. Let's do thumbs up if we think it's a function. Thumbs down if we think it's not a function. Thumbs up if we think it is. Thumbs down if we think it's not. Right? Do you think it is, Brian? I thought you had yeses or nos. Thumbs up if you think it's a function. For this one, thumbs down if you think it's not. It is. Good. Now I'm going to cheat on this one. You ready? I'm going to write function. And then I'm going to write, what does that mean? Same as the other one. Same as the other one. I don't want to write it again. I don't want to write it again. No. And the AP test is very unlikely that you would have 2 in a row like this. So you have nothing to refer it back to. Okay. Same thing on the last one. Thumbs up if we think it's a function. Thumbs down if we think it's not a function. It's a circle. It's not a function. Right. Did you graph circles in geometry? What? You didn't graph circles? It's a shape. You didn't graph circles? Crazy. Not a function. You can even give an example on this one. Almost spelled a bad word. My example would be, you can even find a point here. You can see right here we've got 0, 3, and 0, -3. So when x equals 0, it has 2 different outputs. X equals 0 has 2 different outputs. Alright, we got a couple of wonky graphs on the bottom. These wonky graphs are what are called piecewise graphs. Spoiler alert, why are they called piecewise? Because they're cut into pieces, yes. And piecewise graphs can be functions, they cannot be functions. It just depends on the way they're drawn. Does anyone know the difference between an open circle and a closed circle? Like maybe from like 6th or 7th grade? At least one couple of people. Can you explain what an open circle and closed circle difference is?
An open circle represents that light doesn't reach it, while a closed circle represents that the light reaches that.
Yes. Okay. Closed circle means that there is actual point there that it's going to reach. Open circle means there's not an actual point there. It's not going to reach it. So when you see this closed circle, that's an actual point. Actual point. When you see this open circle here, that's not an actual point. It's just an open dot. There's points right up to it, literally right before it, but not right there where the open circle is. Not a point. So I'm going to do a think, pair, share on this one. Technically ink if you want to write it down. Think, pair, share. Let's take 30 seconds all by ourselves real quick and just think about, would this one be a function? Would it pass the vertical line test? 30 seconds just to think and then we'll pair up. 30 seconds just to think and then we'll pair up. We're still in the thinking phase. We got 20 more seconds just to think. I know some people like to think out loud. Everyone got an answer? Alright, let's pair up. Let's do pink and purples, yellows and greens. What are we thinking? Pink and purple, yellow and green, does it pass the vertical line test? Way to go, Garrett. It does pass the vertical line test. It does, because if you drew a vertical line right here, are there 2 points there? No, there's only one, because that open dot is not a point. So it only crosses this point. What's our reasoning? Good morning, Mr. Now. Don't ask me. I don't know. I know 3 names. Function. Each input is paired with exactly 1 output. Alright. For the next piecewise graph, I'm going to have us write our answer yes or no on a whiteboard. Okay, so we're looking at it. Let's take 30 seconds just to look at it, and then we're going to grab our whiteboard and literally just write yes or no, yes or no. Doesn't matter which one you want to write. We'll prefer the right answer. Feel free to discuss with your group if needed. It's okay. It's a little wonky looking. Again, we're writing our final answer on the whiteboard. Let's see. Alright, boards up. Let's see what we wrote. Wow. And you wrote the reasoning. Good job. Yes, each input is paired with exactly 1 output. I know you're looking at that going, what? How is that even possible? But you can see it anywhere where you put a vertical line. It's only going to hit 1 point. Even this weird little place here. We got 2 open dots, but then we got a closed dot on the bottom. That's a function. Again, I'm going to cheat when I write my reasoning. Same as the one before. Feel free to write the whole thing out to really get it done. Alright, what do we got on the back? Oh my god. Is it a function? Thinking it through. These are pretty challenging. Okay. I'm going to have us do a table talk for this one. For a table talk, what we usually do is each person takes turns sharing their idea. So this one says, what about a function in words? And those words are, would Houston, comma, zip code be a function? Houston, comma, zip code. I'm going to have the person sitting closest to the door share your thoughts first, and then we'll work our way around our table. Just your thoughts. You don't have to necessarily be the right answer, but just kind of like, maybe because of this, or maybe not because of this. I'm loving all these I love the argument. I love it. All right. Anyone want to explain whole group what their thoughts were? Yes.
It's not a function because there's 2 O's in Houston.
Oh, well, it is not a function, but not because there's 2 O's in Houston. You didn't pull in zip code at all. Anna, what are we thinking? Oh, Anna's group. What you thinking?
We said no because Houston has multiple zip codes.
That's the reason. Yes. That's the reason. It's no because Houston has multiple zip codes. I live in 77003. And I live in Houston. This school is in Houston. And our zip code is 77019. Already we got 2. I think there's like 40 of them. Like, there's a lot. So if you plug in Houston and get different zip codes, that's not a function. That was a good thought. Yes. All right, we got a few over on the right to think about also. Person birthday. A person and their birthday. A person and their birthday. Let's give it a quick table talk. What do we think? What a person and their birthday.
Okay, person birthday. One person has birthday person. So it's a function. But birthday person. Lots of people have the same birthday.
God, these are great conversations. Yes. Okay. Explain back there. The first one, person birthday.
Person birthday is a function because one person can only have one birthday.
Yes, one person can only have one birthday. You can be born on 2 different days. So if you plug in me, Julie Brody, you're going to get one day. March 17th, St. Patrick's Day. Isn't it ironic with the red hair? Function. One person. I know. Does that make me a leprechaun? Who knows? Can only have one birthday. If you write the official reasoning, that's okay too. Each input has exactly one output. Okay, backwards. What about birthday person? Why? It's the same thing, just reverse. Right, let's think about a birthday. Oh, I wonder if anyone here has the same birthdays. Yes, if you have a birthday, lots of people can be born on that birthday. Okay. Have you ever met someone that had the same birthday as you? I only know one person. Billy Corgan from the Smashing Pumpkins has my birthday, and that's all I know. I think there was also a serial killer, but we don't want to. Okay, yeah, so this one is no. Multiple people can be born on the same birthday. Okay, that is officially the first half of the lesson. The second half of the lesson, if you look at the title, we are evaluating functions. You actually do this in Algebra 1, and you probably have done it since then. You just didn't know it was called evaluating a function. Evaluating just really means, tell me the answer. What's the answer? Work it out. Tell me the answer. So we're given a function on this first one. It says using the function f of x equals 3x plus 5. In case you didn't remember from Algebra 1, f of x is how you would read that, f of x. And it just really refers to the y value, the output value. So if we look at the first one, I'm going to do the first one for you. We're given f of 2. What this means is we're going to take this 2 and we're going to plug it in for the input, which is x. Plug it in to x. Okay. So given this function right here, sometimes I'll give you two functions, like an f and a g, and you would just, if it said f of this, you plug it into the f. If it said g of this, you would plug it into g. But this one I only have one function, so I'm going to take that 2 and plug it into my x right here. Now, does that make 32? No, that makes 3 times 2 plus 5. 3 times 2 plus 5 would become 6 plus 5, which is 11. So f of 2 equals 11. All right, second one. Let's do together. Choral response. I'm going to take that -3 and plug it in for what, everyone? Man, that was 3 people. Let's try that choral response again. I'm going to take that -3 and plug it in for what, everyone? X. Very good. So same function, still the f function. So we'll have 3 times -3 plus 5. No need to grab a calculator on these, even if you have a personal one. We have brains, and they work pretty darn good. 3 times -3 is? -9 plus 5. I know, everyone forgets that word. Don't worry. I knew what you meant. And then -9 plus 5 is? -4. It is everyone hates to say that word. Probably because it's so negative. There it is. Okay. Before we do the last one, let's do a quick think, pair, share. Think, pair, share on the last one. Let's do 10 seconds just to think. How is this one different than the last one? 10 seconds just to think. We're still in the thinking phase. 10 seconds. 8 seconds. 7, 6, 5, 4, 3, 2, 1. Quick little table share. How is this one different than the last one? Last one was asking us to find the output. This one's asking us to find the input. Meaning we want to take this f of x equals 7 and plug it in for the f of x. Plug in for f of x. And it kind of just creates a little equation, like a 6th grade equation you need to solve. So in my equation, I'm going to put it in the right spot. 7 equals 3x plus 5. I'm going to have you work this one by yourself and put the final answer on a whiteboard. Final answer to this one. Your final answer should be in the form x equals and then some sort of number. I believe it's a fraction. It's okay to leave it as a fraction. X equals some sort of number. Again, final answer should be a fraction, I believe. It's okay to leave it as a fraction. It's a terrible decimal anyways. Your final answer is on the whiteboard. Beautiful. Lots of right answers. Oh my God, you even wrote it in a beautiful format. I love it. Alright, I think almost perfect timing. Okay, hold those boards up. Boards up, boards up, boards up. 2/3. Beautiful. Love it. Proper, even super proper format would be to say f of 2/3 equals 7. Just so it kind of matches the last one. Because your final answer should have said just 2/3. X equals 2/3. If you would have wrote 2/3 on a test, I'd still mark it right. Alright, a little application. Mike Miles loves to annotate. Loves to annotate. Y'all know what it means to annotate? In math, it really just means highlight. We're going to highlight. Sometimes if you don't understand a word, maybe circle it so we can talk about what that means. So I'm going to have us just take 10 seconds just to annotate this question, aka highlight the question. Oh my God, I thought that was lipstick. How cute. 30 seconds just to annotate. Now, one thing that is new for this year, they want us to also write a hashtag next to a paragraph. Okay, here's what my hashtags are always going to represent. I'm going to always write hashtag, and then right next to it, I'm just going to write, what do I need to do? What do I need to do? So it kind of even tells you what you're going to need to do, but they want us to write it again, aka kind of like, what's the main idea of the problem that they're trying to get you to do? All right, here's what I would have annotated. Anyone annotate that equation? Yes. Anyone annotate what the variables represent? H of t is the height in meters. T is the time in seconds after the ball is thrown. And then here's what the question's asking you to do. Find h of 2. So my hashtag, my main idea for this would be find h of 2. And maybe explain. I don't know why they want us to do the hashtags, but here we are. Okay. Let's do it. Okay, I'm going to have you guys find h of 2. Do I not have no response variables? Find h of 2. 1 minute. Let's find h of 2. Let's take our final answer and put that h of 2 on a whiteboard. Put h of 2 on a whiteboard, just so I can see that you can see. Feel free to double check with the gang before you write it on your whiteboard if you're not sure. That's okay. No shame in that. Seconds, but I can add extra time if people are still working. Again, don't grab a calculator. We got real hard working brains. Our brains work harder at this school than any other school. We can do this. All right, let's throw it up on a whiteboard. See if we are able to get it. Very good. H of 2 is 22. H of 2 is 22. All right. Quick little think, pair, share. Think, pair, share. What did that mean? Notice it says explain what it represents. Let's take 30 seconds just to think about what does that represent. You can write it down if you want to, or you can just think about it. 30 seconds just to think, and then we'll share. What did that represent? We found h of 2 is 22. What does that mean in words about this height of the ball thrown into the air? Five more seconds to just kind of solidify in our brains what we thought it meant. 3, 2, 1, and okay. Let's go ahead and share. Let's do pink and purple, yellow and green. Pink share with purple, yellow share with green. Thinking about that.
So h of 2 represents the height in meters or the output of the equation. And it's supposed to represent the ball after 2 seconds with the instant of the So after 2 seconds, it would be 22 meters in the air.
All right, heard lots of good answers. Can I get your repeat answer again? That was perfect.
H of 2 or 22 represents the height in meters or output of the ball after 2 seconds of being thrown in the air. Which is the
Yes, the height of the ball after 2 seconds. Very good. All right, I think we're only going to have time for one last question. We might have to skip the practice SAT question. It's fine. You're welcome to work on it on your own. But we do want to definitely do this one. We're given a function, g of x on this one, x squared minus 5. And we're asked to find g of y minus 6. Totally doable. We can do that. If we go back to think about how we saw this problem earlier, what did we do with the part that was inside the parentheses? We plugged it in. So what are we going to do with the part inside the parentheses? You're going to plug it in. Where are we going to plug it in, though? In place of x. Very good. We're going to take this y minus 6, and we're going to plug in for the x. And then here comes the part that you probably don't remember from Algebra 1. It's okay. It's been a few years. Okay, I've plugged it in. Let's do a table talk on how we would simplify this. I promise you, it is not square the y, square the negative 6. Let's talk to our table. How do we simplify that? It's not just square y, square negative 6. Don't work like that. See, who remembers their Algebra 1?
So you get 5 plus 6.
Algebra 1 for you? Alright, I heard at least one person in each group. Can I have, I don't know your name, hon, the girl in the pink right here. Can you say what you did? Do the parentheses thing, and what was the word you used? FOIL. Yes. Write this. We have to FOIL this. That is the acronym for, basically you're multiplying it together, multiplying two binomials together. Y minus 6 times y minus 6, and then you'll have to minus 5. What does FOIL represent again? Front, out, in, last. It's the order you multiply it. So you're going to do the front one times the front one. What's y times y? Y squared. The two outer ones, that's y times negative 6. That would be negative 6y. The two inside ones, negative 6 times y is another negative 6y. And negative 6 times negative 6, last term would be positive 36. And then I'll bring down my minus 5. Anything simplify in here? Yeah, what simplifies? Negative 6y and negative 6y becomes negative 12y. 36 minus 5 becomes 31. Alright, we are going to stop there for today. If you want to challenge yourself later with a practice